GoldenDent.
Here we have a patient that presents with a maxillary right cuspid tooth that is fractured and was deemed non-restorable. We want to atraumatically remove this tooth. What does atraumatic mean? Well, we want it to be atraumatic for the patient as far as any discomfort goes. We want it atraumatic for us, the dentist, so that we don't have to work too hard in removing this tooth. But even most importantly, we want to remove the tooth atraumatically and maintain that facial plate of bone. It's imperative, as we're considering this patient for a single dental implant, an immediate single implant, that we maintain that facial plate of bone as possible. But we're also aware that in the maxillary cuspid area, the bone can be very, very thin. So let's demonstrate a technique where we can remove a tooth that was deemed non-restorable easily using the innovative physics forceps. The tooth has a fracture, a root canal and a post, and a fracture and is decayed. And you can see here from our CBCT from Vatech that we have a tooth that has a very thin facial plate of bone. And to remove this tooth can be very difficult for us as dentists. Number one, traditionally we would use a periotome to break down the periodontal ligament, maybe take an elevator, but we have crown and bridge on either side of this broken down fractured tooth. So removing it needs to be we need to be very careful in removing the tooth. Here we want to use the innovative physics forceps to remove this maxillary cuspid tooth atraumatically. The physics forceps consists of two components: the beak, which will engage the palatal surface of the tooth, 1 to 3 millimeters subgingival. We want to try to engage the root structure rather than the margin of the crown. If we engage the margin of the crown, especially on a tooth that has a post, we'll probably remove the crown first, which is fine. But in the technique, we want to engage the beak, which is a flattened plate, onto the palatal surface, and we're going to place the second part of the instrument, the bumper, as high up the vestibule as possible. Now, this instrument is rather unique in that we're not using any force to remove the tooth, so I'm not squeezing the handles. Rather, I'm having the beak engage the palatal surface of the root, and then I'm going to rotate my wrist here towards the corner of the right eye, only my wrist, not squeezing the handle, so there's no bicep, forearm, shoulder pressure whatsoever. The handles are simply holding the instrument in place, and we're going to use rotational force to create tension onto the palatal surface of this root. So we're actually going to rotate this tooth up and out of the socket. The tension created by the beak is going to physiologically create an enzymatic action that will reduce or remove the periodontal ligament. It'll actually resorb the periodontal ligament away. Thus, the tooth will be released and will come out of the socket fairly easily. So we're taking our pressure, taking tension from the beak, and you can see I'm not putting any pressure whatsoever on the handles. The handles are there to hold the instrument, rotating my wrist, and the tooth will actually disengage up and out of the socket. The instrument is not intended to remove the tooth in total, rather to disengage it. And I will take what we call a tooth delivery instrument that will engage the root and will simply rotate that tooth out of the socket. You can see it's a fairly long cuspid tooth, and we were able to remove it without damaging the facial bone, plate of bone. Here's a periodontal radiograph demonstrating that. Now, in this situation, we're going to immediately place an implant, and what I want to do is demonstrate that the facial plate is indeed intact. So I'm making a little envelope flap, not placing any vertical incisions whatsoever, and I'm actually elevating the soft tissue, the attached gingiva, away from the bone, both facially and palatally. And you can see clearly that the facial bone is intact, which creates a four-wall defect. We have a socket that should be very easy to restore, to graft and place an implant. So let's look at our second CBCT that demonstrates that indeed the facial bone is intact. It's very, very thin, but it's intact, and it makes our process that much easier. So the innovative physics forceps allowed us to remove this tooth atraumatically for the patient in a matter of minutes, atraumatically for the doctor, and most importantly for me as the implant surgeon to maintain that facial plate of bone.